Hi everybody. So in our last lesson we talked about static electricity. So I'm going to rub this balloon on my sweater. You may have done this before. We'll see how it works because I have hairspray in my hair, but yes, it does work. It likes my hair. It pulls it straight out even in spite of the hairspray. You can see the static electricity is attracting, kind of like a magnet. Hopefully you can see that. Even though the camera gets a little bit blurry. There we go. The balloon acts like it's a magnet, just pulling my hair away from my head. Because when I rubbed it on my sweater, it built up the static electricity. Well, we're about to move to our next chapter, which is a different kind of electricity. It's how magnets and electricity are related. We're going to do this experiment on our Zoom. So we're going to go ahead and read together the very last lesson in our book, Fields and Forces. Think back to what you learned about a magnetic field, an electric field, and current electricity. So here we repeat and just kind of sum up all these different things. A magnetic field is an invisible area in which magnetic forces are present. An electric field is the space around anything with an electric charge. A magnet can have an effect on some objects within its magnetic field. Electric fields surround charged particles, including protons and electrons. Current electricity is a flow of electric charges, or electrons, along a path. So, how are magnetism and electricity related? This is an important paragraph, and tomorrow, when you answer some questions on Jupiter, you're going to need to come back to this paragraph and write it. So keep it in mind where this is. How are magnetism and electricity related? When an electric current flows through a wire, the wire acts like a magnet and produces a magnetic field. A changing magnetic field produces an electric field, and a changing electric field produces a magnetic field. Because of the relationship between magnets and electricity, magnets can be used to make electricity, and an electric current can be used to make a magnet. Interesting, isn't it? It goes back and forth both ways. The interaction of electric charges and electric and magnetic fields is called electromagnetism. An electromagnet is a temporary magnet that works only when electricity runs through it. Remember, we made a temporary magnet at Zoom. An electromagnet is temporary, and it works only when electricity is running through it. It relies on electricity to form its magnetic field. A power source, such as a battery, is needed to produce the current. Think about the electromagnet that you made in the structured inquiry at the beginning of this lesson. By the way, remember that's the one I said we will do at Zoom. If you attach a wire to a battery so it connects the battery's positive and negative ends, it produces a small magnetic field. The wire and battery together form a simple electromagnet. Because they're temporary magnets, electromagnets can be turned on or off by turning on or off the current passing through the wire. Electromagnets are used in generators, which you will learn about on the next page. They are also used in doorbells, televisions, telephones, and computers. Electromagnets are found in cranes that lift heavy metals, motors, appliances, and cars. People use electromagnets every day. All right, we had a picture, which I should refer to, of a worker right here, of the worker using an alternate power source. The power source being used is a generator. A generator is a machine that uses a magnet to produce electricity. It changes mechanical energy into electrical energy. Some generators are hand-powered, while those in power plants are driven by steam turbines, wind turbines, fossil fuels, water wheels, or nuclear energy. You could be the energy source for a hand-powered generator. When you turn the crank on the generator, the coils move around the magnet and generate electricity. All generators follow the same basic principles to work. They produce electricity by moving a magnet through a coil of wire. So how do they produce electricity? They move a magnet through a coil of wire. This causes a current that flows back and forth in the wire. As long as the magnet moves through the coil, electricity is produced. Electricity from a generator can be used to produce light and heat or to power machines. Power plants use large generators to make electricity for towns, cities, and even countries. They produce the electric current you use in your home and school to power lights, computers, and appliances. Most of the electricity produced throughout the world comes from power plants that use generators. Mainly large turbines power these generators. A turbine is a wheel shaped like a fan that spins when acted on by a force, usually from steam or water. Here's a picture of a turbine. Looks like a large fan, and when steam or water, in this case steam, comes and it comes through it, it turns and it moves the electricity, the magnet, through a coil of wire. That's the magnet and the coil of wire which produces the electricity. So they bring in the coal, they heat it up, they make steam, because they bring in the water too, and when the water comes in through these pipes and the boiler, as the fire under it that's making the pipes hot, turns the water to steam. The steam is then brought over and pushed through the turbine or big fan, which spins around, and that spinning fan causes the movement of the magnet through the wires, makes the generator, generates electricity which goes out to our homes. In some places, I don't know if I skipped this. Okay. I think I stopped right here. The fuel used to boil the water may be a fossil fuel, such as coal or oil, nuclear fuel, or solar energy. After the water is heated, the steam flows through the turbine. The turbine is connected to a large electromagnet in the generator. The rotating turbine causes the electromagnet to revolve. The magnet causes electrons to move, making electricity. In some places, water from streams or rivers is collected behind dams. When water falls through the dam, the turbine turns. Power generated by water turbines is hydroelectric power, which we studied about earlier in social studies. Wind power turns turbines in some other places. So instead of using the coal and heating it up to make steam, sometimes they use the wind itself to turn the turbines. When wind strikes the turbine blades spin. This motion then spins the generator shaft and produces electric current. Are there any appliances in your home that move? Perhaps you have a vacuum cleaner, a blender, or an electric mixer. You might have a washing machine, I hope you have a washing machine, and a dryer. These appliances and others have electric motors. Some of your toys may even have electric motors. An electric motor uses an electromagnet to cause motion. It changes electrical energy into mechanical energy. Think back to what you know about all magnets. Opposite poles attract, and like poles repel. An electric motor uses the attracting and repelling properties of magnets to create motion. So just really quick, we have right here a permanent magnet right here, and it attracts and repels the poles of our electromagnetic magnet right here. And our battery is the power source. So we have the wire coil, and we have the permanent magnet, and we have the power source. Those are the things that need to work together to make an electric motor.